Welcome to Azure Backup and Recovery webinar. First of all, I would like to thank you for joining the webinar in the name of the company NIL. My name is Jan Češčut. I'm a system engineer at NIL, primarily focused on different cloud technologies. In the last few years, my focus is shifting more towards Microsoft Azure Cloud Solutions. So in the second part of the Azure Backup and Recovery series of webinars, we will focus, of course, on recovery. The first part, if you remember, was delivered by my colleague Robert, and he focused on Azure Backup solution. To put it simply, without the ability to recover your data and all your critical services fast enough, in a case of a disaster, the backup by itself is of not much use, of course. So you need a system that can bring you back in the business as fast as possible, because we all know that downtime equals lost revenue. We will first take a look at the current state of disaster recovery implementations in today's organizations. Based on this data, we will try to identify the challenges that should be addressed by disaster recovery solutions. Then we will take a deeper look at the solution that is offered by Microsoft, that is Azure Site Recovery, of course. You can also sometimes find Azure Site Recovery under the shortened name Site Recovery, so just to know that it goes for the same product. We will also, at the end of the presentation, have a 10-minute demo where I will try to show you the more interesting parts of Azure Site Recovery solution. Last but not least, we will have also some time dedicated for your questions. As you probably all know very well, nowadays businesses operate on a global scale, and their services must be available 24 hours per day. When they are not, companies of course are losing money, and their customers are usually very unhappy. So business continuity is a must. In such competitive and also dynamic environment, you would expect that organizations are very well prepared for technical failures or disasters. But however, the reality is quite different. Different surveys have shown the majority of organizations are very poorly prepared for situations when their IT infrastructure goes down. They don't have the defined recovery processes. There usually is no system in place, and if they have some disaster recovery configured, there is not enough tests done to be sure that everything works as expected. And as we all know, how bulletproof are not tested recovery plan. Let's take a deeper look at many additional challenges that the organizations are faced today. Because of the complex environments that support the processes that are needed by businesses, usually the protection of such environments that run on maybe Windows operating system or Linux operating system. Also, this can be physical servers, or also nowadays many servers are virtualized and they can run on VMware hypervisor or on Hyper-V platform. Because of all these complexities, there arises a need for multiple solutions to successfully protect these environments. But all these heterogeneous environments presents for IT professionals a lot of work, and usually companies don't even protect also the more critical servers. Also, having a disaster recovery solution is not enough if it cannot recover an environment in a sufficient amount of time, because long recovery times again have a direct consequence in loss of revenue. Also, business continuity creates demand on flexibility. So we could say that flexibility is a must because protecting the whole environment, disregarding the importance of the protected workloads can get very costly. So to put it in other words, if you protect your whole data center, you will have at least that much costs as you had to for your primary data center. So it is usually wise to protect just the most critical servers that your business depends on and leave all the other not protected. So how can we overcome all these challenges? So businesses need a solution that should protect their entire infrastructure. So the solution should protect physical servers running Windows and Linux, and also the virtual machines that run on VMware platform or Hyper-V platform, because these are the two most used virtualization platforms. The solutions should also provide application consistent protection. What this means? It means that if you are protecting an SQL server or let's say mail server that stores the emails in a database, let's say Exchange is such a product, you should first make sure that the protected data is in a consistent state. So to achieve this, you need a product that creates application consistent snapshots and in a consistent fashion replicates the data to the secondary data center. Also, the solution should provide options to configure RPO and RTO attributes. These are the recovery point objective and recovery time objective, so that the organization business needs are met by these settings. Because again, if you set very short time for RTO and RPO, it directly correlates with the increase of costs for implementation of disaster recovery solution. Also, the organization should be able to verify, so to test that their disaster recovery implementation is adequate without impacting the production environment. So the solution should offer to simply establish a test environment where everything can be checked, and this will acknowledge it also when really the disaster will happen, everything will also work on production environment. So all these challenges are addressed, or at least many of them, by Microsoft Azure Site Recovery Solution. So what can ASR really do? ASR can simplify your business continuity and disaster recovery strategy. How? By eliminating secondary data center, but of course if you configure and use ASR in such a setup. It is also possible only use the replication feature of ASR and replicate the data into the Azure, or only to use the orchestration feature of ASR and leave the replication between two on-premises data centers. We will take a little deeper look on this scenario in further slides. Also, ASR allows you to monitor the state of the replication, and it will automatically notify you if any problems arise. It will also provide flexible replication, because you can protect only a part of the workloads that are critical to your business, and it provides easy failover. But of course, any disaster recovery solution should also provide easy failback, because it is important to go back to your primary data center when you are fully back online. And it is good that the solution integrates with your existing business continuity and disaster recovery technologies, like, let's say, storage replication. If you have already implemented storage replication between your primary data center and secondary data center, ASR won't touch this replication. It will only orchestrate migration of workloads if a disaster will occur. So it will start your protected servers in the secondary data center when the primary goes down. Also, the data and communication between Azure cloud and your on-premise data center is always encrypted. Now we are talking about the data on the fly. The other part of the encryption is related to call data, so the data that is replicated into the cloud. There is an option to encrypt also the data that rests in Azure storage. It is not possible to encrypt the data on your secondary data center. So if you're using ASR to act, let's say, as a middleman between two on-premise data center, the data on the secondary data center won't be replicated by ASR because the tool only acts as an orchestration utility. You will have to implement some other solution to encrypt the data in such a scenario. When your workloads are moved to Azure, you can take advantage of all the cloud services that Azure Cloud provides. So you could use the multi-factor authentication. You could also run some data analytics on the data that you have migrated into the cloud. We can say if ASR is correctly configured, you can extend your data center with additional features that are provided from Azure Data Center. ASR can also be used for fast and quite simple onboarding process. What does it mean? ASR for the first month is free. In this time, you can test that all your workloads work as expected in Azure, and only then, when you are satisfied, you can move all the workloads into the Azure cloud. By all this, ASR also allows you to quite simply build a development or test environment in Azure or also in your secondary data center. How can this be achieved? You can use automation library. This is, let's say, an API that can be used to call your PowerShell scripts, and you can then build quite complex environments by triggering a failover, a test failover, and scripts will automatically, attach some additional virtual disks to the virtual machines in test environment, or they will provision the virtual machine in a certain way that you need for your development. To create a summary in a few sentences what is possible with Azure Site Recovery. So Azure Site Recovery in fact helps you to orchestrate the replication and failover and also the recovery of workloads and applications so that they will be available from a secondary location. This can be your on-premises secondary data center or Azure data center if for some reason your primary location goes down. Let's take a more detailed look on different scenarios that are available for Azure Site Recovery. The first one and the most commonly used is to replicate and orchestrate the disaster recovery from your on-premises data center to Azure Cloud. Usually this scenario is implemented if the organization doesn't have a secondary data center, and by all this it means that it is also a good solution for smaller companies, and they get the same enterprise-grade level disaster recovery solution and can only, let's say, replicate just one server that is critical for their business. The ASR can be, in such a scenario, can be configured to protect, of course, Hyper-V virtual machines. It can also protect VMware virtual machines and also physical servers that run Windows or Linux operating systems. By protecting Hyper-V virtual machines, it can also communicate with your System Center Virtual Machine Manager and then both together orchestrate the replication of the virtual machine. The secondary scenario that I also mentioned during the previous slides is the ASR acting as a middleman between two on-premises data centers. Using this kind of setup, ASR acts only as an orchestration tool for disaster recovery. So ASR controls and monitors the replication between the data centers, but the actual data replication is done by some other solution, let's say a storage replication of the data. So ASR will orchestrate the failover and then also the failback of the protected resources. And the same holds true regarding the supported platforms. VMware is supported Hyper-V and also the physical servers running Linux or Windows operating systems. I have included a table, let's name it replication matrix, because here you can see all the environment that are supported by Azure Site Recovery, and the table speaks by itself. The ASR is very flexible and has a solution for almost all of the challenges that we were speaking at the beginning. And also one feature that I almost forgot to mention it is that all these different platforms are configured using one common configuration portal, that is Azure portal. Also, there are some PowerShell cmdlets available for you if you want to configure using the PowerShell, or if you are building a script that will automatically set the replication up. Okay, this is almost all about the first part of our webinar. Now we will move to the second part, that is the demo. Just to give you some context where the demo runs, we have two Hyper-V hosts that are managed by Virtual Assistant Center Virtual Machine Manager in our data center, and we are using Azure Site Recovery to first replicate the virtual machines into the Azure cloud, and then also to orchestrate a test failover, and we will also look into different kind of failovers. So let's move to the demo. Let me just first log in into the Azure portal. We are using the new Azure portal. Some services haven't been yet migrated to the new portal, but fortunately the recovery Vault service is already on the new portal. This is the recovery services vaults. We have two vaults. We will be using the second one. And if you remember from the last session that my colleague Robert gave, using the Azure backup feature is also available from the same portal. So at the beginning, when we log into the Recovery Services Vault portal, we are presented with some dashboards. Microsoft named these pages as blades. So this is a blade that I've just closed. This is also a blade. Let's first check some of the features that are available in Azure portal under the Recovery Vaults section. We will first check under the jobs. So here, if I click jobs, I have to choose site recovery jobs. I will see all the jobs that have been completed or also failed or are still ongoing from the time that the vault has been created. This is something that's, let's say, somehow interesting. Then we can move on and let's check the replicated items. Here you will find all your virtual machines or your servers that are included in the Azure Site Recovery replication. As you can see, we have 1, 2, 3, 4, 5, 6, 7 virtual machines running on Hyper-V that are currently being replicated from our on-premises servers into the Azure cloud. So this is an ongoing replication. Let's say that I click on one of the servers and I will get some additional info about computer network, so to which network the server belongs. Also about the disks that are currently replicated. As you can see, Here it is possible to select what instance will be deployed in Azure Cloud when we make the failover of this particular server. So here you have all the virtual machines that are available to buy and to deploy in the Azure Cloud. And let's leave it as currently selected. This selection is done automatically based on the dedicated resources on to the virtual machine on your on-premises infrastructure. So here it is also possible to manually select a network. So in Azure data center, it is possible, of course, to have many different networks. At the moment, we only have one for this demo, but we could, let's say, choose another network for test purposes, and here we would create a manual bind, particularly for this server that we are protecting. If we move back to settings blade, and we will go under the site recovery infrastructure, under the manage part. Here you can see that we have settings for each individual system that is supported by ASR. So we have some settings for System Center Virtual Machine Manager. This is what we are using. It is also possible to configure ASR on VMware and physical machines and on Hyper-V servers that are not part of the System Center Virtual Machine Manager. So this is one thing. Then we have another interesting part under the Azure Site Recovery. These are the recovery plans. So this is the most important part of Azure Site Recovery. Here we create recovery plans, and we can also, of course, also customize them. This is the orchestration part of Azure Site Recovery tool. We will come back to the recovery plans in a few short minutes, but for now I will first show you on our on-premises infrastructure how the addition of Azure Site Recovery agent to the server integrates with the System Center Virtual Machine Manager. So this is our on-premises Virtual Machine Manager running on our servers in data center, and if we deploy another virtual machine, I will simply choose a virtual machine from a template. Next, I will give it a name. Let's give demo virtual machine 3. Let's click next, and here under the hardware part of the deployment wizard, we have here a Microsoft Azure Site Recovery section, and we have to enable Microsoft Azure Site Recovery protection for this particular virtual machine. Otherwise, the Azure Site Recovery service running in Azure Cloud won't detect that we have a new virtual machine that we would like to protect. We will use the default replication frequency 5 minutes, and just clicking next. Let's deploy it to the virtual machine to a private cloud. Let's click next and choose the host that will on which the virtual machine will run, and let's also give the new virtual machine a name. Next and create. Now it will take around 4 to 5 minutes for the virtual machine to be created. We won't wait for this. I just wanted to show you how the Azure Site Recovery settings are seen in the deployment wizard. Okay, let's move back to our Azure portal. Now I will add some additional virtual machines into the replication. Let's click again on our recovery service vault, and here under, if you remember, the replicated items, I currently have just 7 virtual machines that are currently replicated into the Azure cloud. I will add some additional virtual machines. The first step is to choose the source. The source is our on-premises system centered virtual machine server, and because we have only one, it's automatically selected. The cloud is also only one that also is selected, so let's click OK. The target will be, of course, our Azure data center. This is West Europe, and it should also be pre-selected. The subscription is also selected, and also which deployment model we will use. As you most likely all know, Azure is being migrated for the classical model of deploying virtual machines into the resource manager. This is the one that also this portal runs on. So the resource manager model has some nifty additional features that weren't available on the old portal, but not yet all services have been migrated to the new one. So you still have an option to use the old one. The storage account is also pre-selected. We will just leave everything as it is. And now we have to select the virtual machines running on our on-premises data center. As you can see, the Azure Set Recovery in Azure detected that there is one virtual machine that hasn't been yet protected. And if I move back to our on-premises server, I should be able to see this particular virtual machine, and it is this one. Also, if I check under the protection, it is disabled. If I, let's say, check on any other virtual machine, as you can see, this one, the protection is enabled, and there were no errors. So we will be adding this particular virtual machine into the replication policy. Let's move back into the cloud, and let's confirm the selection. Here we have an option to configure some settings related to the PhD disks for this particular virtual machine, but as we only have only one disk, nothing can be really selected. Just here we have to select the OS type. Let's click OK, and some additional settings regarding the replication policy. We can have many different replication policies. What in fact is a replication policy? This is the policy that dictates frequency of the replication. As you can see, it is in this particular policy done every 5 minutes. Then if there will be any application consistent snapshot done, and yes, it will be done every hour. How long the data will be retained in the cloud for 2 hours. So we have an option to go 2 hours in the past and get the state of the particular virtual machine at that time. And something else about encryption. So it's also possible, as I have already mentioned during the presentation, to encrypt the stored data in the Azure. But currently we have this disabled. Okay, let's confirm the settings and let's enable the replication. Now, if we check under the jobs, we should see this particular job. Okay, enable protection. Let's click on this, and we will get some additional details. So yeah, some prerequisite checks have been successfully done, and then it goes on, and it will most likely take around 20 minutes or even more, because it has to do the initial synchronization of the data. That means that it has to copy all the data, the whole size of the virtual disk of this particular server into the cloud. But ASR is quite intelligent, and it creates some duplication. It checks if the particular blocks are already in the cloud, and if the service finds the blocks, it simply will reuse them and won't copy the blocks from on-premises data center into the cloud. It can also copy, let's say, a virtual machine of size of 10 gigabytes or even more quite quickly, depending what you have already copied into the cloud. Okay, so we've added some additional virtual machines. Now we will create a recovery plan. So this can be done here under recovery plans part. As already mentioned, we have some plans already created, but let's create a new one. Source again will be our on-premises server. The target is Windows Azure, and we will choose the resource manager model and select the virtual machines that will be included in this particular recovery plan. Okay, we'll choose this particular machine and this one, and also the SQL. Okay, let's confirm. The new recovery plan should be created very quickly. Yeah, the recovery plan, demo recovery plan 4 has been created. Let's click on it, and we get some additional information about this plan. Okay, we can customize it by clicking on the button Customize, and here we get some detailed info about the plan. And as you can see, first it will shut down all virtual machine, all 3 virtual machines in the first group. Then it will fail over these virtual machines into the Azure cloud. So all groups fail over means that the Azure Site Recovery in the Azure cloud will connect to your System Center Virtual Machine Manager on premise, shut down these virtual machines, and start them in this step in the cloud. So also before this, the virtual machines will be deployed, because now only the files exist, but not the compute part of the virtual machines. So it has to deploy the virtual machines, connect the virtual disks that are already copied via replication in the cloud, and then in this step start all these 3 virtual machines. Again, it is possible, of course, to add and to create some changes. Here I can add a pre-action step. This is, if you remember from the presentation, I was mentioning the automation service. Here I can add a script, a PowerShell script, and I will name it start store simple virtual appliance, because we have a Store Simple Hybrid Cloud storage installed in our data center. We can script that when this recovery plan starts, before starting the virtual machines that are included in the recovery plan, it will also start the virtual machine that is dedicated for Store Simple in the cloud, and these virtual machines, after everything has been done by the script, will be able to access the volumes via this Store Simple virtual appliance running in the Azure cloud. So here I can choose some settings related to this automation step. I can choose a runbook name. Runbooks contain scripts, let's say, and that's it. So it is also possible to use a script when you are failing over from Azure back to your on-premises data center, and you could have also some scripts, some PowerShell scripts installed on your on-premises data center and use them when the failback occurs. But we won't use them. Let's just click OK. So we have created a pre-step that contains a PowerShell script that will do something. Also, it is possible to click here and add a post-action step. So when all these virtual machines will be started, there can also be another script call that would be run after everything is booted up. Okay, so let's save this, and then we will just for this demo run a test failover of this particular recovery plan. Okay, changes have been successfully saved, and now clicking here on the test failover, we start the testing process. We also have to select the target network in which the virtual machines will be created. You have a warning that you must be sure that this virtual network in Azure isn't an extension of your on-premises virtual network, because it could happen that then you would have two identical virtual machines, one running in your on-premise data center, one in Azure, and this can of course cause problems with your production environment. So you should create a test network dedicated only for these test failovers. Okay, we will choose our network, and now the test failover is started. Again, it takes quite some minutes to complete, so we won't be waiting for the test failover to finish, but I will just show you under the jobs again blade how the individual part of this failover looks like. So now it is creating the test environment. This means that it will start creating virtual machines in Azure Cloud. And then you can click on each individual step and see how long it took to complete it. We will move to a recovery plan that was run some hours before our presentation, and each test recovery plan, when everything is completed in the cloud, is in the status waiting for user input. What does it mean? It means that when the virtual machines are successfully started in Azure, in this particular recovery plan there is only one virtual machine, the recovery plan will wait for the user, for the administrator, to click on this button, complete test. That means that we've tested the environment, everything looked like was working fine, so we can finish our test failover. If I click on this complete test, the ASR will clean the virtual machines. I can also show you in Azure portal that this particular virtual machine really exists. Let's go under the virtual machines section, and here you will see that we have demo rp-2-test. This is the one that is also included. See, when running the test failovers, the ASR automatically append word test at the end of the name of particular virtual machine, because you have to know that this is a test virtual machine that is there only temporarily. So this is the naming convention that is used by ASR. Okay, I will now click complete test. Also, let's check this box. You can write some notes, and let's click OK. And now the process of cleaning up the test environment will start. As you can see, failover is moving towards its end. Complete testing successful. Now it will clean up the test virtual machine. Let's check here what is going on with this virtual machine. Deleting, you see. So in a few minutes, this virtual machine won't exist anymore in Azure. Okay, now again we won't wait for this process to finish, because we don't have enough time, and just the last part of our demo will be related to another recovery plan. This one, demo recovery plan 3. This plan was also run for some hours before our presentation, but it was run by clicking planned failover. What does it mean? If I click on planned failover, it means that it will fail over the production of virtual machine. So it won't deploy and start the virtual machine in a test network. It will shut down the production virtual machine and start the virtual machine in Azure Cloud. So what is different here is that now we have also to reverse when our data center, let's say, comes back on premises, we have to reverse the replication and fail back this virtual machine back to our on premises. Just a moment, if you click on commit, we will acknowledge that this virtual machine has been successfully started in Azure. Also, let's check which virtual machine is this. We can click on customize to see how many virtual machines are included in this demo recovery plan, and it looks like there's only one, and its name is demo RP-3. So let's click here and check the virtual machines, and yeah, as you can see, it is here. And if you remember, the other virtual machine has been successfully deleted. So this virtual machine, let's say, is a production virtual machine. Okay, let's move back to our ASR portal, and here, when this is committed, we can again click on planned failover, but this time the ASR will replicate all the changes that have been done in Azure to this particular virtual machine back to our on-premises environment. As you can see, the source is Microsoft Azure. The target is our System Center Virtual Machine Manager running on-premises, and data synchronization. We will choose to minimize downtime. What does it mean? It means that firstly all the changes will be replicated, and then as a last part, if there were in the process of replicating changes any other additional changes done, it will finally replicate everything and shut down the virtual machine running in Azure Cloud and start the one in your on-premises data center. We also can check this one. So if for some reason there is no virtual machine in our on-premises data center because we had an outage and we lost everything, ASR can automatically also create a virtual machine. So let's click this, and again a new job will be created that will deploy the virtual machine in our data center on premises, and it will afterwards remove this virtual machine in Azure Cloud. Okay, let's check the job, and as you can see, there are many different steps in this planned failover recovery plan. So now it's preparing the on-premises virtual machine in our on-premises data center. So it's this one. Okay, that was all from my part for the demo. I hope you enjoyed it. I just created a quick overview of the features and how to configure them in Azure portal. There are, I think, still some minutes for the questions. We have two questions. The first one is from Darin, if I pronounce it correctly. So, hi, if I understood you correctly, you pay for each protected instance in Azure Site Recovery. Are there any other hidden expenses, if I may say so? Yeah, a good question. So that's correct. As I've mentioned during the presentation, you pay only for each protected instance, and of course you also have to pay for the storage space that is consumed by the replicated data into the Azure cloud. So if you have, let's say, a 50 gigabytes sized virtual machine and you replicate it into the Azure cloud, you will also have to pay for the data in Azure cloud and for the protected instance. And then if an accident happens in your on-premise data center, the ASR will start the virtual machine in Azure cloud, and you will pay for the used CPU resources and memory, so for the time that the virtual machine runs in Azure cloud, and also of course for the data that is transferred from Azure to your data center or from anywhere you access this protected virtual machine. We have one additional question, and it's from Igor, and his question is what operating systems are currently supported by Azure Site Recovery? As also mentioned during the presentation, it is possible to use Windows operating system and Linux on physical machines. So Linux and Windows are of course supported, and also the hypervisors Hyper-V and vmware is also included in ASR. Other operating systems don't have any agents, any ASR agents available to be installed in the operating system. So at the moment it's not possible to protect them. But I would say that if you run, let's say, operating system, let's say a free BSD operating system or OpenBSD or something more exotic on your Hyper-V cluster, you would be able to protect this virtual machine as any other virtual machine. And it would be simply replicated into the Azure cloud, but you won't get, let's say, application aware replication and any other advanced features that are available in Azure Site Recovery. This I'm not 100% sure, but I would say it is supported, such scenarios. So yeah, maybe you could say that there are some additional platforms that are supported by ASR. Okay, I think that this will be everything. I don't see any additional questions. So thanks for attending and have a nice day. Bye-bye.